One, two, three. Hello. Okay, it's working. Hey everyone, thanks for coming in, and it's great to see this good group of people here. We are very excited to be at Scalar today, and for you guys to hosting us and sponsoring us today. We're gonna have two great presentations today with by Luke and Mishra from Hootsuite, and I'm personally very excited to see that. But before we start, I want to ask Jason from Scalar to tell us a little bit more about Scalar, what you guys are up to, what you guys are doing here. I know that you guys moved to this place recently. What can we expect from Scalar?
Great. Yeah. Thanks a lot. Hey, everybody. I'm not going to spend a lot of time up here trying to sell you guys things or anything like that. So I just wanted to welcome you guys all to our new office. So Scalar Decisions, we just moved into this space. We got everybody on one floor now, which is great. So we got about 60 people in the Vancouver office now, which is pretty awesome. We got a great new view, which is fun. And you guys are our first event that we've had in the office. So welcome, everybody. Glad to have everybody here. So for those who don't know anything about Scalar Decisions, and I'm going to assume most of you don't, we're a data center, security, and cloud company. So we started about 13 years ago, purely in the data center space. About 4 or 5 years ago, made some heavy investments in the security space as well, doing integration, consulting, managed services. And the last 18 months has been where we've really doubled down on our cloud strategy. So we're kind of focused on the enterprise in British Columbia and Canada across. And we're kind of selling to the $1 billion plus guys, which is great. But the problem is that we can't fill all the holes that we have in our staff. So one of the reasons why we wanted to do this event today was to get into the grassroots levels with you guys, providing some beer and pizza and some conversation, and kind of get to know what everybody's skill set is out there in the market, because we're doing these massive projects and we need help. So, welcome to our space. I'll be around after. If put your hand up if you're a Scalar person in here. You're not a Scalar person. I need your shirt. If he tries to sell you anything from Scalar, don't buy it. I don't know this guy. Okay, fair enough. So anyways, just meet us grab us after if you want to know more about what we do, but we do want to contribute to the community, and that's why we're here today. So I'll pass it back to the team here, guys, and enjoy yourselves. Thanks everybody for coming.
All right. I don't think this mic is working at all. Is it? All right. Okay, cool. So my name is Luke Kysow, and I work at Hootsuite on Kubernetes. We've been using Kubernetes. Well, we've been working on Kubernetes for about a year now, year and a half, and we've been running it in production fully for 8 months. And so tonight, the talk is going to be basically an overview of Kubernetes. So quick show of hands, how many of you guys have heard of Kubernetes? Okay, that's a bad one, but you can keep your hands up. Okay, good. This shows me how many people are willing to put their hands up to give me a good sample size. How many people are using Kubernetes or have used it? Okay, and how many people are running Kubernetes in production? Okay, awesome. So luckily, we got a good overview that I can go through of what the heck Kubernetes is, because I know it sounds really cool, but what is it? And then I'm going to start with the basics. So, okay, I've convinced you that Kubernetes is really nice. Now I want to run my application on it. What do? So the first thing you need to do is figure out how to get your app up on Kubernetes. So that's what we're going to do. I'm going to live code out getting an app running on Kubernetes. And then now that it's in Kubernetes, great, the app's running. Like you can run apps anywhere. Why would you run them on Kubernetes? I'm going to go through some of the cool things you can get for free out of Kubernetes, especially in Google Container Engine. Once that's done, it's going to be a half-hour talk. It's going to be mostly coding. We're going to take a break, have some beers, a little more pizza. Mr. is going to come up, and he's going to take the next step. Say you've been running on Kubernetes and your business got really hot, and now you need to serve traffic across the world. This is a problem where Google has been able to serve traffic across the world, for years, but a new startup, like they're just hosted somewhere in Canada or whatever, they can't actually necessarily get all the data centers around the world. So Mr. is going to take that, like just a small app in Kubernetes, how you can use all the tools in the Google Cloud Platform and get your app running across the world. So look forward to that. So just going to move into Google Cloud Engine here, Google Container Engine. So Google Container Engine is Kubernetes managed Kubernetes, or Google Cloud Platforms managed Kubernetes. So you can find it on the dashboard here. Okay, go away. Over here, you go here, you click Container Engine. This is Kubernetes, but you can create it through Google here. So you can create a cluster by just clicking the button. You can also do it through command line. Pick your name, pick which region you want your cluster to be in. Pick the version of Kubernetes you want to use. Here you can pick the machine type. So you can run multiple different machine types in your Kubernetes cluster. So if you're doing something really like GPU intensive, you can have a cluster of machines only for GPU intensive things. But this is like on average what your normal node pool is going to be for Kubernetes. We'll just leave that up here. This is how big your cluster is. But you might not know exactly off the top of your head how big it needs to be. So you can also add in auto scaling. So it can scale depending on how big your workload is. Automatic node upgrades would upgrade your nodes to the latest version of Kubernetes. Disable. I don't know why you would ever not turn on automatic node repair. I guess it's like a little bit buggy. It sounds good. And there's a bunch of stuff here, and you can click create. And it's going to take about 5 minutes for this all to get started. So I'm not going to have you guys sit around and wait for that. So I already got my cluster started here. So once you've got it up and running, you click connect. You copy this to your clipboard. You paste it in. If you have gcloud running. Now you have kube config set up. So now your laptop is ready to use kube control, which is the Kubernetes command line tool. I run kubectl proxy.
Just like put your hand up if you're scared. I heard that. I I'm like,
Yeah, we can hear you in the other room. So now it says I've got a proxy running on localhost port 8001. So if I go over here to localhost 8001/UI, we should see the Kubernetes dashboard. So, it takes like about 5 minutes for this cluster to spin up. But once it's ready, you're running Kubernetes. That's how easy it is. Now, this might not seem revolutionary, like, yeah, wow, I'm running Kubernetes, great. So what you're actually seeing whenever you look into the Google Container Engine is you're just seeing your node pool. So, you get 3 nodes is what I spun up in that cluster. And so that's great. This is your compute resources. But what you're not seeing is actually what's happening under the hood. So at Hootsuite, we actually run Kubernetes on Amazon. And on Amazon, they don't have any of this nice click button run Kubernetes stuff because it's just letting you guys all move to Google. So they make you do it the hard way. So if you do it the hard way, you need to spin up all this stuff. So we'll start at the top here. So these are controllers. These are basically the control plane for Kubernetes. This is the brains of the operation. This is where all your API calls go. So that kubectl commands I'm running, those are sending API calls up to the control plane. This is where the scheduler runs and a bunch of other critical systems for Kubernetes. So this is all being managed by Google Container Engine. You don't ever see these nodes. This is etcd. Have everyone heard of etcd? Heard about console? So etcd is a distributed consensus data store. So it's a highly available data store that Kubernetes uses to store all of its objects. So this cluster basically contains all the information. etcd contains all the information for Kubernetes cluster. So if you lost all the data and you started Kubernetes up again, none of your workloads will be running. So this is critical, right? Now you don't see this in Google Container Engine because they're managing it all for you. This is part of the reason it takes a couple minutes for them to spin it up. But this is the control plane that you don't have to see when you're running on Google Container Engine. And speaking from experience, having run this on Amazon, you don't want to have to manage it because it's really important. And so you have to do a lot of HA stuff with it. You got to test it. You got to make sure it's all working. And Google's been running Kubernetes for years, and they don't have to worry about that. So what is Kubernetes? So, there's been a lot of ways. Kubernetes at its base is just a platform on which to deploy your application. So great. Like, what about Heroku? What about Google App Engine? What about actually just deploying directly to Google Cloud Platform? What about Amazon? There's been ways to deploy your application for years, right? So what's so great about Kubernetes? Now, this is my opinion, and some people might have other opinions, but there's a couple things that make Kubernetes really special. And the reason, 100 people sign up for this meetup, 200 people are signing up for these other meetups, like it's hot right now, right? Everyone's interested in it. So why? What's so special about it? There's a couple things. The first one is that Google has found the right level of abstraction that appeals to all of us engineers. So, Heroku's great. You just do, who's used Heroku before? You have your app. Okay, if you haven't used it, you basically have your app and it just runs locally and you go like git push and boom, it's running on Heroku. But it's too magic. You don't know what's going on and you don't trust it and you can't do certain things with it. So the level of abstraction is too high with Heroku. I don't really trust it for running my production workloads. And then you have something like Google Cloud Platform where you're actually spinning up your own VMs and everything and you're making your own deploy pipelines, you're getting everything on there. So that's great. That's a really low level of abstraction. You can do whatever you want there. But then again, it's really slow. You don't get the kind of cool tooling you really need to make things fast. And so when we're in this world of microservices, we've all been really pushed to be able to spin up these new services really, really fast. And so, this is just a generic picture of an application. So you have the internet, it comes into a load balancer, it hits one of your 3 application instances that you're running for high availability, and it hits a database. Now, for the longest time, everyone's thought their app is special. You know, oh no, I can't run this on your platform because I need this and this and this. And I can't run this app on this platform. I'm going to need this and this and this. And over the years, we've kind of realized that there is an abstraction. There is some names you can put to each of these parts, and you can fit in your app to all these different things. So the names in Kubernetes are a service. So this is a load balancer. This is an endpoint you can hit, and it's going to route to one of your service instances. Then you have your pods. These are the individual application instances. I don't care where these pods are running. I don't care which node they're running on. All I want to know is that the service routes to the pod. Okay? Now I have a deployment. So I don't want just a single instance. I want multiple instances. I want to manage rolling them when I do a new version update. I want to make sure that if that pod goes down because the node it's on goes down, it comes back up. So, you know, in Amazon, this might be auto scaling group. You know, there's lots of different names for this. And so in Kubernetes, the name for it is deployment. And finally, you know, I need state. I need somewhere to store my data. So I need a persistent volume. But I don't really care where the volume is, like where the computer is. I don't want to like be worried about like my master MySQL database and SSHing into it and making sure it's safe, right? All I really need is I need my cloud provider to give me a disk, and I need a pod to run my SQL on, and I need a service to be able to route to MySQL, right? So you see like the same primitives that we're using for the app is the same primitives we can use for the database, right? So you can see how these pieces start to fit together. And I want a persistent volume. So if my pod goes down, I want you to, whenever it comes back up on some other node, I want you to mount back in my data because I sure as heck don't want to lose all my MySQL data. So this is kind of the magic of Kubernetes, and we're going to get into each of these primitives. But the way they fit together has just really made it a great confluence of abstraction that makes it really easily. And so the kind of what Kubernetes is saying, and it sucks as an engineer to hear it, but it's basically saying your app, to me, is just Docker images and YAML files. And no matter what you're building, the world's best application, you know, the world's smallest application, I can describe exactly what you need in a YAML file and a Docker image. And, you know, it kind of like sucks. No, my app's special, right? But no, it's not. I can take your app. You can tell me what it needs to be. I can describe it in a YAML file and a Docker image. I can put it up to Kubernetes and be running in seconds. So that's the overview of Kubernetes. And so I'm going to just get into packaging your app up to get it running on there. And I can't use this, so. Now I'll just talk really loud. You can all hear me? Okay, so that's the last slide. We're going to go into code now. So how many of you guys write Golang? What is it? Golang is basically, Golang's a C-based language that Kubernetes is actually written in. And it's really, really simple. And one of the nice things about Golang is if you're running a Python application or a Ruby application, you need to gem install these libraries and everything, right? You need to install these things into your environment to make your app run. And this is kind of where Docker came along. Docker was great because you could, who's used Docker before? Okay, cool. So Docker's like, okay, just package all the stuff you need from your application into a single Docker image. I know it has everything on the file system there. Now I can take that Docker image, it's a container, it's an abstraction. I can run it anywhere, right? So I don't need to make. Okay. Okay. So like I was saying, with Docker, it makes your app an abstraction. So it's again like your app's not special. As long as it can run a Docker image and bind to a port, you're good. Anyway, so I digress. But basically, Golang doesn't have all the problems that you have with Ruby and Python, where you need to have everything like in your on the file system to actually run your app. So Golang compiles down to a single binary that you can run anywhere. And so kind of like the JVM, but you don't actually need the JVM. It just runs straight on the system. Anyway, it's very simple language, and so this app will make sense to you guys. So here, in my main package here, this is the main function. So I'm gonna get the host name. So this is the host name of the service system that I'm running on. And I'm gonna use this later to show that we're actually load balancing over different instances. The node name, this is the underlying node that I'm running on. Now I did mention before that you shouldn't really care about the nodes because Kubernetes handles scheduling you into different nodes and you shouldn't really worry about it. But for the demo, it's kind of interesting to see that you're actually on different nodes. I have two routes to this HTTP application. The first route is / and it returns OK. And the second route is the route that actually does something. So it's /hello. And so I'm expecting, in here, I'm going to look for the query. So it's going to be something like, greeting equals hi, like this. So I grab that greeting. And all this app does is it counts how many times each greeting has been given to it. So I'm just going to increment a map up by 1 based on that greeting every time. And finally, I'm going to print it out to the user. Hello from %s would be the host name on %q, which is the node name. So that's like the underlying host I'm running on. Because on your Docker image, your host name is not necessarily what your node isn't going to be the same as the computer you're running on. And then it tells you, I've seen that greeting, %d times, and here's the version in which I'm setting up here, because we're gonna do rolling deploys. That's it. So I'm just gonna switch over to the terminal here. I'm gonna get out of the, actually, I'm gonna keep that kube proxy running. Just bring it up here. Any problem seeing that code? Okay, so I'm just gonna run that app. And now I'm gonna curl localhost 8080 slash, well, slash is just return okay. And then slash hello, and then greeting equals hi. That's return hello from, this is my host name on this. There's no environment variable for that right now. I've seen the greeting 0 times, and if I could call it again, it's gonna say 1 times, 3 times. And if I change the greeting, it's gonna say 0 times. So very, very simple app. So now I have my app running. It's great. Golang is super easy. So now I want to package it into a Docker image because Kubernetes works on YAML files and Docker images. So I need Docker images. So to build a Docker image, you need a Docker file. And this describes how to package your app up into an image that Docker can run. So the first line here is from. So this is the base image that I'm going to build off of. So I'm going to go from Ubuntu, the operating system. This is nice because when I exec into the pod, I actually have like different tooling I might want to use inside there. Add is basically a glorified copy. It's going to copy app, which is where I'm going to compile my Golang app. I'm going to compile it into a binary, a file called app. It's going to copy app into the Docker container. And the entry point is the process that the Docker image is going to run when it runs, when it starts up. So it's just going to run /app. So obviously app is going to be executable. So to do this, all I do is docker build dot in the current directory. So it says it successfully built this container here. So now I'm going to run it. So I'm going to go, well, I didn't compile my app, so I should do that. So go build. So this compiles the Golang app into this -o app, and it's going to compile it for Linux because I'm running on Ubuntu, right? Good. Okay. So now the app is compiled here. So now I can run the Docker build. Okay, we got our container. So now I should be able to run this. And I want to publish the ports to my localhost. So I'm going to go publish port 8080 to 8080 so I can curl it because on a Mac, Docker is actually running up in like a VM. On Linux, you don't have this problem. So everything works fine. So that means my app is now running, although it's interesting because now it's running in Linux, not on my Mac, right? That's kind of cool. So now you have your Docker image. It's called this, which is a bad name. So I'm going to tag it as Kysow /GCP-meetup. I've got this tag. Now I'm going to push this up. This is pushing it up to the Docker registry. So now I can pull it down into my Kubernetes cluster. So far I haven't really touched anything on the Kubernetes side of things. I'm just running all this stuff locally. So now that I have this app, I'm going to wait for this to push here. So now we want to talk about Kubernetes. So as I mentioned on this presentation here, this thing is a pod. So the first thing I want to build in my app is a pod. And a pod is basically just your app. A pod can actually contain multiple containers. So how many of you guys run PHP? Okay. So PHP, when you run it, you can't just like, you know how I could just go run and then my app is working? So PHP doesn't work like that. Well, I mean, it does kind of, but most of the time you need to run Nginx in front of it. So you might want to actually, your app might actually be like Nginx and PHP together, right? So in that case, it makes it sense to run both those containers in a pod together. But for a lot of apps, you just need to run one Docker image per pod. And pod is just Kubernetes name. So this is the YAML files I was talking about. So the primitive, the kind here is pod. The name of the pod is going to be GCP Meetup. And the image, the one I just pushed to the Docker registry, is going to be Kysow /GCP Meetup. The name of the image inside this thing is going to be GCP Meetup. I like that name. And then this is an environment variable that I'm going to pass in. Kubernetes is going to pass in for me. And it's going to tell me a little bit, it's going to leak some information that I probably shouldn't need to care about. But for Mishra's demo, it's kind of cool. It's going to tell me which node I'm actually running on. What's the underlying instance? So how do you get this running in Kubernetes? You just run kubectl, apply, and pass in the file. So now it says this pod's been created. So now I'm going to look at what's in the cluster. So I can go over to here and refresh, and we should see it. So that's that pod there, GCP Meetup. We can look at its logs. It says starting server. But I tend not to use, as an operator, I don't really use the UI very much. So I mostly use the command line. And you can do everything that you can do in the UI, you can do in the command line. So the same thing I would have done there was kubectl get pod. It's listing the pods I have running. So I have this one here, and I also have this other pod in here, but I'm using kind of as a bounce box to get into the cluster. So I can do the logs there. It's got the same logs. I was talking about using this debug box as a bounce box, but you can actually port forward your local, just with the Docker image, I was publishing port 8080. I can actually port forward up all the way to my Kubernetes cluster, which is running in like, where is it running? Okay, well this was fast, this cluster too, but you didn't see it actually shown up. So yeah, Central East for them. But I'm gonna port forward here, my port 8080 to its port 8080, but I don't need to say it. And I can port forward to the pod. Okay, that was the backwards of directions, 8080. So now I'm port forwarding from my laptop up there. So you can see that I haven't even asked like, hey, which node is it on? So I haven't SSH into the node and then like found the Docker image and then like done a port forward, right? It just, you have the tooling there. You don't really care about what node it's on. So I should be able to curl this again and it's working, but now it's running Kubernetes. Okay, that's cool. So now we have this pod running up in Kubernetes. Was there one more thing I wanted to show you there? No, I think that's everything. So we have this pod running in Kubernetes. But kind of one of the downsides that it's running in a pod is that, say you have a single instance of something, right? A single server or something running, and someone does this. Pod GCP meetup. Someone accidentally like, oh, hey, Luke, I accidentally deleted that server you just spun up. I hope it wasn't important, right? So now it's not running. And so now, this is kind of a bad thing. So like, you're like, well, what the heck's the point of Kubernetes? I want it to actually like be cool and like, make sure my apps are running properly, right? So that's where we bring in this idea of a deployment. So you're actually never really going to see just a pod description. What you're more likely going to see is something like this, a deployment. So you can see it's almost the same YAML, it's just a little bit different. So that pod here, I basically just copied this into a deployment. But there's one additional thing here, replicas, 3. So Kubernetes is now going to handle scaling this up to 3, and it's going to handle watching it to make sure it's working. But everything else here is the exact same. So let's deploy that. So now it says the deployment was created. And if I go kubectl get pod, you should see we have 3 pods running now. And they have a different kind of weird name. Before it was GCP Meetup, now it's got this random name because there's 3 of them. So I can do the same thing. I'm going to go get pod-o wide. This is going to show me the IP address within Kubernetes. So another really cool thing about Kubernetes, if you've used Docker before, you know that like in most systems, because you're running like say 6 Docker images on a single node, right? So how do you hit the Docker image? Like what is its IP address? What's its port, right? So you have to like map the Docker image port to somewhere on the host, and then you got to somehow find out where that is, right? So with Kubernetes, no. Every single Docker image, every single pod gets its own IP address, so it's routable everywhere. So again, you don't have to really think about the host. And it's really cool how that works. And if you're interested in how that's actually working, I can talk to you afterwards. But anyway, I've just grabbed one of those IP addresses here, and we should see that that's still working, but which is not. It is 8080. Oh, I'm not in the cluster yet. Okay. Meet greeting. Okay. So now I have this deployment running, right? So this is great. I have a deployment, but it's got 3 IP addresses. And so like, if I want to consume this from like somewhere else, like, what do I just like, it's the same problem with the ports. Like, how do I know where it's at? So, in my diagram, we have the pods, we have the deployment. Like, what are we missing here? What are the routing piece? What's the routing piece? The service, right? So I need the service. So we look over here, service.yaml. We got our service, and the name is GCP Meetup. And what it's doing, it's selecting which pods to route to. And it selects which pods to route to based on this label, app GCP Meetup. So if we go back to our deployment, we'll see it's been labeled as app GCP Meetup. So it's going to know what to put in its back end based on those labels. So it's going to run on port 80, and it's going to point target port to 8080. So let's run this.
So you're saying it does port translation, 8080 to 8080.
Yeah, exactly. So now this is created here. So now I should be able to curl GCP Meetup. So like, you're like, what? How can I just curl this random host name? So Kubernetes has a built-in DNS resolver. So now I don't need to go 8080. It should just be 80. That should be fine. hello, greeting. Hi. Okay, cool. So now it's saying hello from this one. I've seen that greeting 4 times. So now you see it's a load balancing over them, right? So let's just run that in a loop. Do curl. This is going to silence the annoying output. The other S is going to make sure you see the errors if they happen. I think I need to create a new line. I'm going to sleep for 1 second, and then I'm going to keep looping here. So here you see we're load balancing over 3 instances. That's pretty interesting. Now, what if I scale it? So we're running out of real estate here. Well, what I'm going to type in here is kubectl scale -- replicas equals 5. Then I'm going to scale my deployment. You should see down here, it's starting to create these new pods, and they're up and running here. So now I'm actually load balancing over 5 different things. So now you see starting to see the power of Kubernetes. You know, like, yeah, I got my app packages running on this cluster, so what? But now you can do things, a lot of things with it. You can do a lot of different manipulations with it. I don't know if I showed you, like, let's scale this back down to 3 so it fits on one screen. And I'll just do this. I'm gonna watch it because it's better output. Okay, so it's running 3 here. And so what if I delete? So say I delete this 1P2J one. Kubernetes is gonna recognize that one of them's deleted and it's gonna bring another one up. So this one just came out 3 seconds ago. So that's kind of that HA thing, right? Okay, so that's really cool, but like, what the heck is up with this count? Like 1 time, 31 times, 30 times, 0 times, 25 times, like this is not accurate, right? So, you know, we have these stateless apps here. We need some state, right? So, you know, you reach to something like MySQL or Redis or whatever, right? So what do you need to run MySQL and Redis in Kubernetes? What primitives do you need? So you're gonna need a pod or a deployment running Redis. You're gonna need a service that routes to that Redis thing. So I don't need to look up his IP address every time. And if you want to make it persistent, you're going to need a persistent volume, which is we haven't gone into. But I'm going to start with the first part there, which is the pod and the service. So here's the abstractions, right? They're really easy to work with. They're the right abstractions. So if I open up redis.yaml here, this looks very similar to the other deployment I had, except I have one replica. The name's Redis everywhere. And instead of running my image Kysow/GCP Meetup, I'm running Redis, which comes directly from the guys at Redis. So this is that deployment. It's going to create one pod. It's going to watch it, make sure it's always up. Now we need a load balancer to point at it. We got our service here. Its name is Redis. It's going to be a selector. It's going to select on app equals Redis. So any pod with name labeled app Redis, and here this one's labeled. And then we're going to run it on port 6379, which is the normal port for Redis. So all we need to do is run kubectl apply-f service Redis. Now it says this Redis deployment's been created. If we scroll down here, we see Redis is running. Okay, that's good. And let's see if that works. So if we netcat to 6379, let's play ping pong with Redis here. Okay, so it's working. That's really cool. Now let's see how we deploy apps with Kubernetes and how fast it is. So it's really fast because I've already written the code for it. So what I'm going to do here is I'm just going to comment out this code. And oh my gosh, how did this show up here? Okay, this is almost the same though. Like there's not that much difference here. So version is 2. That's different. The Redis host, I'm getting it from an environment variable. I'll show you. I'm going to show you that why later. But basically, this lets me change the host name of Redis if I want. But by default, it's going to be Redis, which I named the service. So this should all work. I'm getting a Redis client here. I need to import the HTTP handlers. It's the same routes. But before I was, if you look up here, before I had this map, which was local to each instance. That's why the counts were off. So now I'm actually just going to be calling out to the Redis instance. I'm going to be getting the number and I'm incrementing it and I'm printing it out all the same. So what do we need to do to get this running? Well, we need to build a Docker image, right? So we go build. We're going to build up our app here. Wait for it to compile. Okay, non-declaration statement outside function body, main line 49. Oh, look at that. Now, what's this complaining about now? Okay, should that work? Okay, so we're going to compile it. We're going to pop it into the Docker image there. We're going to tag the Docker image as v2. So I'm going to tag this one as v2. We're going to push this up. So it's going to push it up to Kubernetes cluster. So that's great. We have this image pushed up. It's going to push up to Docker. But now we need to update this, right? So now right now it's running all the version 1, and now we don't want to run version 2. So we just need to go over to our deployment. We need to change the image name from this one to v2. That's it. That's how easy it is. So I'm running 3 of these. I'm going to curl this in a loop again. So I want you guys to watch for this version 1. We should see it turn to version 2. So I'm going to go kubectl apply -f deployment.yaml. And we should also see down here, yeah, there. We should see a rolling deploy happen. So by default, Kubernetes will bring up a new one, bring down the old one, bring up a new one, bring down the old one, right? And if anything goes wrong, it's going to stop that deploy. So we see that containers start to be created. We're still on version 1 here. We're now on version 2. So there's some timeouts happening here because I don't have health checking on the actual app. It kind of complicates the YAML, but you would want to run that in production. So now we're load balancing on different apps here, but you'll notice that the count is going up normally. So our app is now kind of looking like this over here, where we actually have some state. So, you know, very, very simple changes here, but we make this work really easily, and it's all kind of using the same abstractions. Now I don't have time for this, but the other thing I was going to show you was like, you know, that's great, but Redis is running in memory right now. It's not persistent, right? So, you know, that's not HA at all. So this is kind of where the Kubernetes community comes in. So now you have these abstractions. Other people are like, oh, well, I know how to run Redis in HA mode. I'm going to create what's called a Helm chart. So if I look up Helm Redis, this is like a package manager for Kubernetes. So you go over here, we have this Helm chart for Redis, and it's done by Bitnami. And what it's going to use is it's going to use a persistent volume. So kind of what I talked about, where it's going to ask Google Cloud Platform, give me a volume, attach it to my pod. I'm going to save my state there. If my pod gets deleted, bring it up somewhere else, reattach that volume, and now I still have my state. So this is a complicated chart. There's a lot of stuff going on here. Like there's a lot of different options. If we look into the templates here, like I was showing you a really nice YAML, like we got some gnarly YAML over here. Like just because I said you could put your app into YAML doesn't mean you actually want to. But you know, this is all here, but all you need to do is run readme this. So if I want to run Redis, all I need to run is this Helm install, and then this stable Redis, which is that this here over here, and it's going to install that chart in. So this is where the power of Kubernetes community comes in, where you can actually, because the abstraction layers are so great, you can be all these guys who actually run Redis like all the time. They can build this chart for you, and they'll be like, "This is the best way to run Redis. We figured it out." There's so many charts out here in the Helm repos. It's really interesting. So that's kind of the intro to running your app on Kubernetes. So to sum up, so we went over what you get out of Kubernetes. So you get, you know, self-healing, you get really easy scaling. Then if you turn on auto scaling, you can actually just scale the node pool underneath. You get load balancing. I showed you how it does a rolling deploy. You can do all different sorts of deploys if you want to. It also does rollback. So I didn't show it, but you write kubectl rollout undo, and boom, you're back to the previous version. So now you have your app in this environment, this very programmable environment with the right level of abstractions. It's so powerful what you can do, and it's so fast. So Hootsuite, we went from deploying our stuff to Amazon, you know, waiting like weeks for ops version servers. Now we can build a new app in 5 minutes. And so that's really powerful for a business, and it's also just really freaking fun. So yeah, thanks a lot, guys. I guess I'll do like some quick questions, and then get you guys some beer and just like go to the washroom, and then we'll come back. Yeah, go ahead. Yeah. So the question was, how do you manage Redis cluster? So for those of you guys who don't know, Redis cluster is like you run multiple Redis nodes, and they're kind of replicating between the two of them, and then you have like a Sentinel. Is it still use a Sentinel to watch it? Right. Yeah. And so it's watching those, and it comes down, it brings them back up. So there's a Helm chart for that, I'm pretty sure. But what it does is it has this idea of stateful sets. So with those pods, they had a really random name, right? Kubernetes also has this idea of a stateful set. So each pod will have an auto incrementing ID. And so now you can service discover based on the auto incrementing ID where the other pods are. And then you can also set it so that, say you're doing a rolling maintenance across your cluster. And so you're actually draining stuff off your node because then you just shut it down. So Kubernetes is smart enough to be like, oh, okay, I know I need quorum on my Redis cluster. I need at least 2 out of 3. So I won't let you tear down this node unless this other one's up and running, unless I have a minimum of 2 running. So it kind of manages that all across there. So there's a lot of other primitives. I didn't really get into all of them, but if you go over here, the Kubernetes API, so all those like the pod, the service, all this stuff, right? This is all over here. So that's that stateful set I was talking about. And so there's lots of other little edge cases where, not edge cases, but like kind of more interesting deployments. And most of them are covered in here. They're just a little bit more complicated. But yeah, it does. You can easily run clustered Redis there. Yeah.
What would you do different if you did this in production? Like this is a good interaction. So is there anything specific you should be careful about doing it in production?
Yeah. That's a really good question. So at Hootsuite, we don't run Redis or stateful like MySQL or anything on Kubernetes right now. We just use kind of like Google Cloud Platform's managed databases because that's still dangerous. You know, Kubernetes is still like a new technology, and you know, if the whole cluster goes down and you lose everything, it's a big problem. So that's what we don't do. But I know a lot of people are running like CockroachDB and like fully in production, and so a lot of companies are doing that. So that's just something we don't do. But other than that, the only other thing was, you notice how I was doing that deploy and I got like that error where it said like couldn't connect to port. The reason for that is that the app didn't cleanly shut down, and that Kubernetes added it to the load balancer pool before the app was actually ready to accept HTTP traffic. So they've already handled that. They have this thing called a readiness probe, which will ping your app, and it won't add it to the load balancer until the app's ready. And then it'll be there and it'll be ready to serve traffic. So that's kind of the big one. Other than that, like we fully run deployments and services at Hootsuite and in production, and it works great. Nothing other than that's changed, and just moving the state out of the cluster for now until we're like more operationally ready for it. But yeah, good question.